Well, hello again and welcome to the VK6CS amateur radio channel. I've been doing a few bits and pieces with my linear amplifier project high voltage power supply. As you can see, I've got some meters sorted out here. I've got this one here, and that is actually going to be the anode voltage, plate voltage meter that's bolted to the amplifier front panel. I've got this wired at the moment, as it would be sort of permanently. You can probably see there's a 0.01 decoupling capacitor just across there, and I put the wires on the meter, and they will stay there. You know, those wires are long enough that once I've got this right, they'll be trimmed from the other end and then just soldered onto this board here. Okay, now is that a reasonable enough angle? Should be able to see that, I think. Okay, let's put that on the 1000 volt DC range. Excuse me. Okay, so a very quick look at the power supply board itself. There we go. This is the chopping board. You may remember I bought for $5. Well, I think I bought that, and there was two in a pack, you know, from Kmart for like $5 or $6. But these 7 of these 1000 microfarad 450 volt capacitors in series. Each one has a 220k bleeder stroke balancing resistor across it. They probably do a fine job at balancing. They don't do a terribly good job of bleeding. It takes forever to get the HT voltage to come down. So come down to 0 once the AC is taken off. So I'm going to be replacing these. Originally there was going to be 2 of these in parallel across each capacitor, so it'd be about 110k across each capacitor to balance them up and to bleed the power to ground once the AC was removed. But because of the way it's constructed, I only wanted to use one resistor. So what I'm going to do is I'm going to use 47k ohm resistors, 10 watt, rated at 10 watts, rather than these rather than the higher value smaller wattage. I'm going to go for the smaller value higher wattage. It will stiffen that HT line up as well. Now just these are the rectifiers down here. Let's just see, I might be able to zoom in on that a bit. These are 1000 volt 6 amp rectifiers. Each one's got a 0.01 capacitor rated at 3000 volts across it. This is the bottom half of the bridge. This is identical arrangement here up here on the top half of the bridge. Sorry about that, I think my shadow's getting in the way. There we go. Now these cables here, my 2 high voltage cables here, this is actually not what I'm going to be using. This is just a temporary lash up just to try it. Now this is the inner from RG213 coax. This is rated at 3700 volts, so it's going to be fine for the test. I'll show you that arrangement. I mean, that's connected along there to my HT transformer. There we go. There's my HT transformer. You can see the variac there in the background, and that's going down to my HT board. Now, what I've done with this HT board, if I can tilt the camera forward enough. See, I've mounted an extra capacitor clamp here. These are nylon capacitor clamps. They've got flanges on the bottom. Although the chopping board is not conductive material, it's a good idea to use these. I like using these capacitor clamps with the flanges at the bottom, so that if you do series capacitors up and you've got a conductive board that you're bolting them to, the cans are not going to touch that board. Now these, I didn't want to use a printed circuit board, although these capacitors are designed for use with a printed circuit board. Personally, I don't like the idea of using printed circuit boards with high voltage power supplies. Get dry joints on the capacitors. If one of the capacitors lets go, you could blow a hole in the board and then have to make another board. So I much prefer with high voltage type stuff to mount it like this. Then if one of the capacitors explodes, cut it out, put another one in. Too easy. Right, now then, oh yeah, because these are designed for mounting in printed circuit boards, these are sort of offset. If these were screw terminals, I would have mounted them the other way around. I would have mounted them 90 degrees, rotated them through 90 degrees, and then just had a straight line, because I could have put a couple of solder tags on each post, you know, one for the interconnection, one for the resistor across each capacitor, and that would have all been in a nice straight line down there and down there. Because they're printed circuit board type capacitors, I couldn't really do that. I did actually try initially having them through 90 degrees, these connection points, and it didn't look right. I couldn't get the wires straight because these are sort of slightly offset. So I ended up mounting them the way I've mounted them, and I've ended up with this rather fetching sort of artistic resistor design. Resistor mounting arrangement. Yeah, it's almost a shame actually that the side of the amplifier won't be transparent. So I think that looks quite good, but still, there we go. That's probably because I haven't had my medication today. Alright, well, let's always zoom that the wrong way, par for the course. Okay, did I move this bloody tripod? Now, let's see if I can. There we go. Righto. So now I'm going to apply some volts. Excuse me. Got a bit of a cold, so I'm even more croaky than usual. Let's apply some volts and see what happens. So what I'll do is I'll wind the variac up so that we get 1000 volts indicated on here. Now this meter, show you the meter. There we go. Now this meter is 0 to 30 volts, and what I've done is I've put some resistors in series with it to make that 0 to 3000 volts. Now that's a 30k ohm coil, apparently, internal resistance on this meter. So I want it to read 100 times the voltage. 100 times 30,000 is 3 million. So I put, and let's say it's 3 megs minus the 30k, and put that value resistor in there, and that should then read 0 to 3000 volts. So I did the calculation, and there we go. Excuse me. This string of resistors here was to provide the correct series resistance to make that meter read 0 to 3000 volts. It doesn't though, not quite, which is why I've got this, this is where I've just been fudging around with it here, just tacked some extra resistors on while I'm sort of mucking around with these values. But what I think I'll probably do is I'll put a pot in there and just adjust it, because it's not going to track linearly. And what I mean by that is that at 1000 volts it might be reasonably accurate, but at 3000 volts, which is where I'm more interested in it being accurate, it might not be. I'll show you what I mean. So if I come out always the wrong way, there we go. Okay, well, I'll apply some volts and I'll get 1000 volts indicated on this meter. Okay. Now the shaking is caused by two things. One is that I'm leaning around a tripod, and two, I'm leaning around a tripod and over a high voltage power supply. Okay, right, so let's wind on some volts. This is in the evening, so I've got an overhead light. I'm not really sure if that's right on the line. Okay, that's about 1000 volts. Now, yeah, that might be just a whisker above. Might just be a whisker above 1000 volts. That's indicating there. Now this meter here will measure does have a 1000 volt DC range on it. It's selected to 1000 volts DC. So if I put a probe on my HT line, yeah, you can probably see that that's going over the that's pegging the end there, and because they're connected together here, this isn't grounded. It's picking up a little bit of noise when this is picking up a little bit of noise when I put that probe on. Okay, so let's do that going. So you can see 1000 volts there. It's over 1000 volts there. Now if I measure that on my high voltage probe, now I know this probe's pretty accurate because I just used a battery for reference really. This is a divide by 1000 probe, and I got the numbers I was interested in, so I know this probe's pretty accurate. And you can see on this meter, on the digital meter, it's showing 1.08. Remember, that's times 1000, so that's 1080 volts. Okay. Now this showed over 1000 volts. This is showing about 1000 volts. So this is showing a little bit low, I would say, at the 1000 volt, in the 1000 volt area. So now I'll wind it up to full AC. You can see that meter going up. It's 1500. There we go. It's 2000 volts. It's 2500. And it appears to have run out of steam. Now this should be doing a lot better than a paltry, what do we have here? So that's 2600 and a little bit volts. You could hardly run an LED on that, could you? So that meter there, obviously I can't measure that on this one here. It's a 1000 volt range. 2600 volts this meter is saying, indicating. It's actually not saying anything, you know, as you can probably tell by the audio track. Okay, so I'll put the high voltage probe on, and if you can see on that digital meter, it's showing 2.95. Okay, you're going to settle down. 2.96. Remember, we've got a very high, these balancing bleeder resistors here, very, very high resistance, so it's not providing much of a load to this this power supply. When I put the 47Ks in, it'll stiffen it up a bit, be a bit better. So I thought this should be about 2800 volts, so that's saying 2.95, so that's 2950 volts. 2950 volts. Yeah, there we go. Get the probe on properly. 2950 volts. Okay, so that being the case, this meter here should be, this needle here should be just below the 30. So 2800 volts is that line just to the right of that needle. 2950 should be almost on that line by the 30 there. So where I'm interested in this meter being accurate, it's not accurate. It's not too bad at 1000 volts. When we get up to the 3000 volt end, it's not too flash at all. So what I'll do is I'll take this mishmash out here. No, actually, let's before I start waving my screwdriver around over the high voltage board, I'll just wind that voltage off. That's probably a good idea, isn't it? I don't want to be spending the rest of the week in a vase. Okay, well, let's just be on the safe side. I'll turn that off. Now, there's no AC being applied to this high volt board at all, and you can see how slowly this is coming down. It will come down much quicker once I've changed those resistors. Yeah, so what I need to do is, that's staying in focus, I'll take this this bird's nest out here. I mean, that's okay, this will probably stay. That was wired as a permanent thing anyway. I'll take this little bird's nest out, I'll put a pot in there, and I'll adjust the pot so that 2950 volts actually indicates in the correct place on there, because I'm interested in this being accurate from 2 to 3000 volts, not really between 1 and 2000 volts, if you see what I mean. Okay, so that's how the work on the high voltage board is going. Is there anything else I was going to say about this high voltage board? No, I don't think so. I think that's pretty much it. So with that, I'll say, as always, many thanks for watching. Hope you found that interesting, or amusing, or entertaining. And thanks for watching. I'll catch you next time.